Hey guys, welcome to brainAttic. So today we have another very interesting problem from the topic of limits and derivatives. This question was asked in JEE Advanced 2021. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So the question given to us is let f be a function with domain from minus pi by 2 to pi by 2 and range all the real numbers r is a continuous function such that f of 0 is equal to 1 and integral over 0 to pi by 3 ft dt is equal to 0. Then which of the following statements is or are true? So it is multiple option correct type of a question, and let's see what the options are. The equation fx minus 3 cos 3x is equal to 0 has at least one solution in 0 comma pi by 3. And in the second option, we have the equation fx minus 3 sine 3x is equal to minus 6 by pi has at least one solution in 0 comma pi by 3. Then we are given two limits and we have to find the value of those limits. So let us begin. This question basically applies the concept of Rolle's theorem. Rolle's theorem. So we'll first go over what the Rolle's theorem states. So we have if a real valued if a real valued function, let's say f, real valued function f is continuous on a proper proper closed interval, box bracket a comma box bracket b, a comma b box bracket, and is differentiable on the open interval open interval round bracket a comma b round bracket close, and f of a is equal to f of b, then then there exists a at least my bad there exists at least one value c in the interval a comma b, open interval a comma b, such that f dash of c is equal to 0. So this is what Rolle's theorem states. So if a real valued function is continuous over the closed interval a comma b and is differentiable over the open interval a comma b, and fa is equal to fb, that is the extreme values are equal, then there exists a value c such that f dash of c is equal to 0. Now let us, for option a, let us define a new function g of x, which is equal to integral over 0 to x ft dt minus sine 3x is equal to sine 3x. Now this g of x is continuous and is also differentiable and is also differentiable. So this too satisfies the condition. Now g of 0 is obviously integral over 0 to 0, which is 0, and sine 0 is 0, and g of pi by 3 is equal to integral over 0 to pi by 3 ft dt minus sine pi. So sine pi is also 0, and this is given to us is equal to 0. So g pi by 3 is equal to 0. So for Rolle's theorem, we satisfy all the three conditions. Therefore, g dash of x. So Rolle's theorem, conditions for the Rolle's theorems are satisfied. So g dash of x is equal to fx minus 3 cos 3x is equal to 0. Therefore, there is one solution. Therefore, g dash of x equal to 0 has at least one solution in for x in for x belonging to 0 comma pi by 3. So our option A is correct. Now moving to option B. In option B, we'll apply the similar concept. Now we'll define a new function, suppose phi x, which is equal to integral over 0 to x ft dt plus cos 3x plus 6 by pi x. Now, what we are going to do, we know that this is continuous because each of them are continuous, and this is also differentiable. Now we'll search for phi of 0, phi of 0. So integral over 0 to 0 is 0 plus cos 3x, cos 0, 1 plus 6 pi into 0, which is equal to 1. And we'll check for phi pi by 3, phi pi by 3. Now this integral obviously is given to us, so it is equal to 0, and this is nothing but cos pi, my bad, cos pi plus 6 by pi into pi by 3. So this is minus 1 plus 2, which is equal to 1. So phi of 0 is equal to phi of pi by 3. So all three conditions are satisfied. Therefore, if I find phi dash of x is equal to, it's nothing but fx plus minus 3 sine 3x plus 6 by pi is equal to 0. Therefore, phi dash x is equal to 0 has at least one solution for x belonging to 0 to pi by 3. So option B is also correct. Now going to option C, we have to find the limit. So this limit is fairly easy. So for option C, we'll examine limit is given to us as limit x tends to 0, x integral over 0 to x ft dt by 1 minus e power x square. Now we'll apply L'Hospital's rule to it. L'Hospital's rule. Now the condition to apply L'Hospital's rule is that it should be of 0 by 0 form. You can check that it is by in the order of 0 by 0 form. So we have limit x tends to 0, limit L is equal to x of fx plus integral over x ft dt. So we first apply the differentiation on this term, and in the second part we apply the differentiation on this term. So we have minus 2x e power x square. Now again we find that this is of 0 by 0 form still. So I apply L'Hospital's rule, and this gives us L is equal to limit x tends to 0 fx plus x f dash x plus fx by minus 4x square e power x square minus 2 e power x square. Now when we apply, we see that this is 0 plus 2 f of 0 by minus 2, and f of 0 is given to us as 1, since f of 0 is given to us as 1. So 2 by minus 2 is equal to minus 1. So option C is also correct. Our limit is actually equal to minus 1. Now going ahead finally to the option D, we examine that the limit given to us. Suppose now I call this limit as P. Limit x tends to 0 sine x integral over 0 to x ft dt by x square. So this is in the 0 by 0 form. So we'll apply L'Hospital's rule. L'Hospital's rule. So we have P is equal to limit x tends to 0 sin x fx plus cos x integral over 0 to x ft dt by 2x. Now this is still in 0 by 0 form. So we can apply the L'Hospital rule again to it. L'Hospital's rule, will apply it again, and what we now see is that P is equal to limit x tends to 0 cos x fx plus sin x f dash x plus cos x fx minus sin x integral over 0 to x ft dt In the numerator, we have this term, and in the denominator, we have 2. Now, when we apply the limit, what we see is 1 into f of 0 plus 0 into f dash of 0 plus 1 into f of 0 minus 0 into 0 divided by 2. This gives us nothing but 1 plus 1 divided by 2, which is equal to 1. So this is plus 1. And the option given to us says that this limit is equal to minus 1. So option D is incorrect. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.